in this problem, let's try to understand which of these three functions represents the original function f. Let me put it in black. F of x. Which function is its derivative, and which function is its second derivative? It's a little bit a challenging question, but let's work through it together. I know that when the derivative is positive, the original function is increasing. Increasing means going up. The tangent line has a positive slope, right? Slope is positive. Increasing or going up means imagine if you're hiking a mountain, that means you're hiking it up, so it gets hard to hike it. If the derivative is negative, the original function is decreasing. The slope is negative. So now you're hiking downhill, right? So it gets easy to hike. But the same thing with the second derivative with respect to the first derivative. The second derivative is just the one derivative of the first derivative. I mean that we took the first derivative and then took one derivative of that function. So the same logic happens there as well. I want to look at the line first because it kind of looks simple. And I'm talking about line C in green. Here it is. I see that line C is always going up, but that's not what I want to look at. I want to see if it is a derivative of some kind of function, where is it positive or negative? What does it mean for function to be positive or negative on the graph? That means that whatever is above x-axis, that's when this function is positive, because the outputs are above the zero level, right? This is the zero level. Here you go, 0. Whenever the function is below x-axis, then the outputs are negative. So this function c is positive right after this point and negative right before this point. I saw it on the graph. I wonder if I can find any function from blue and or red that is decreasing here, where the green function, or let me color code it like so. Wherever green function is negative, can we find any other function that is decreasing? Which means if you hike that function, you're going downhill. And I see blue. Do you see that the function in blue, which is function A, indeed is going down and down and down until this point? Down, down, so decreasing, it's decreasing. And then the hike changes. I'll do it here. After this point, the line is positive because it's now above x-axis, and this blue curve increases. Let me write this down. It's increasing because now you're hiking up. Moreover, this point over here is a local minimum, which we're going to be talking about more in the future. So I definitely can tell that C is the derivative of A. So the curve C, which is a line, was created from differentiating a curve A. Now I want to go a little bit further. Either A is a derivative of B or B is a derivative of A. I'm kind of curious about that. Well, let's talk about A again, but now from the same point of view as we did with a line. A is positive. Let me change the color to different. Over here, it's above the floor, above the ground, or above x-axis on the interval I just indicated. And then it becomes negative over here. There's a little, let me just erase the highlighter and use them again. So positive because it's above the ground. Then it dives down below x-axis and gets out of it again later. So let me highlight. In blue, the curve A is positive, and in yellow, it is negative because it's below the ground. So imagine it's like ocean and waves. Can I have a function that will follow the same behavior? If a is a derivative of another function, then when a is positive, another function should be increasing on exactly the same interval on x-axis. And x-axis are here, remember that, right? And I see it in b. b is indeed climbing up, going up and up and up until the same point, which is 0, 0, by the way, where a was above the ground. Below the ground for a, its derivative, now the original function of that of a, should be decreasing. Let me write down over here. This was negative. What function I'm talking about? Negative a. Thus, the original function should be decreasing. Let's look at b. b indeed, maybe it's hard to see now because it's like too many things happening. b is in red. It's going down. Here you go. It's going down. Up until this point. And when the wave, that's how I like to see it, in blue, wave starts being positive because it takes out higher than x-axis. The original function there should be increasing. And indeed it's going up, which is a little bit hard to tell, but if you increase or zoom in the graph, you will see it. So b behaves like this, increasing when a is positive, decreasing a little bit when a is negative, and a is negative a little bit. Maybe that's why it's hard to see, but it still decreases there. And then a becomes positive again, so b is increasing again. I'm talking about b. Thus, a is the derivative of b. So the order of function was like so. b was the original function, a was its first derivative, and c was its second derivative. It also makes sense from the point of view of if you take derivative of polynomials, they become flatter and flatter. So the first graph I was looking at was a line for that case, because I knew that whatever was curly first will be less curly after that. Less curves are happening, and even less curly after that. So b was the first one, and b was actually in red. Let me put it in red. It was like this. Hopefully, now you have more intuition to work on the problems like this. I know it's not very obvious, so keep practicing. Then good luck.